So this is going to be part 2 of a combination of 4-2 and 4-4. What we're going to be talking about here is evaluating exact values of sine, cosine, and tangent. We did a little bit of this in part 1, but now we're going to really get into the meat and the nitty-gritty of what trig really is. This is by far the most important thing that we do in trigonometry is this section, is starting to understand how to find sine and cosine values and what to do to find the exact values. So, looking at what we have here, when we say exact values, we are trying to say that we want to make sure that we can write things in terms of square roots and not decimals. So we're really taking the calculator out of this in most cases and finding a way to display this. What I mean by this is like you're going to see answers like the square root of 3 over 2 instead of saying, not 0.866 repeating. Okay, so we are going to leave our answers in terms of this. So you are not going to really be able to rely on a calculator to do a lot of this. Now, I know on your paper even this is hard to see, but it kind of shows you a lot of the answers that they're in terms of, and we're going to kind of get into this a little bit later. So let's talk about an instance where you might need to use a calculator, and sometimes you'll be told, use a calculator to approximate. So there is a difference between an approximation and an exact value. Approximate means you can use a calculator. So we have two different types of things here. This first line here, we have two angles that are in degrees. So the thing is, if you're going to use a calculator, you need to make sure that you're in degree mode for these ones. So you'd put sine of 122 degrees in your calculator and you'd get 0.848. You put cosine of 237 degrees in your calculator, you get negative 0.544. And you can try these on your own. If you're getting these, then you know you're in degree mode. To get to degree mode or radian mode, which is going to be the next part, you hit mode on your calculator, and then you go down and you select the one that you want to, make sure you hit enter. So these are going to be radians. How do I know they're radians? Because there's no degree sign. So you put tangent of 5 right in your calculator, and you get negative 3.38. Put sine of negative 2 in your calculator, you get negative 0.909. And again, the only issue that you should have here is if you're in the wrong mode. So that's really all there is to it for the approximate values. Now let's get into how we're going to find exact values for our trig functions. Reference angles are singly the most important thing that you need to understand. If you understand reference angles, then you will absolutely understand, you'll definitely understand how to find these exact values. Reference angles are the hardest thing at first to understand in what we're trying to do, but you'll kind of see why we need to do this. So let's start with what does a reference angle mean? Well, a reference angle is the smallest angle from the terminal side of a ray. So we write a terminal side of a ray. It's the smallest angle between that ray and the x-axis. So for example, let's say we are dealing with, we want the reference angle of 100 and, no, you know what, let's try something different. Let's say 210 degrees. What you want to do is 210 degrees is you first need to find it. So we did this in an earlier section where we had to find where 210 degrees is. Here's 90, here's 180, here's 270. So 210 degrees is going to fall somewhere here. And what we had talked about was, here's our initial ray right here, and here is our terminal ray. What a reference angle is we know that it's 210 degrees to get all the way to this line from our initial ray. What a reference angle is saying is we want the smallest angle between the terminal ray and always the x-axis. So we want this angle right here. And that's how you find reference angles, is it should always be an angle between 0 and 90, and it always needs to go to the x-axis. So how do we figure this out? Well, if we know that this entire angle is 210, and we know that we have 180 degrees right here, we can simply do 210 degrees minus 180 degrees is equal to 30 degrees. So the reference angle for 210 degrees is 30 degrees. And usually what we're really looking for is what is left. we went to 180 degrees. Well, how many more degrees do we have to go to get to this ray? Okay, so that's one example of a reference angle. So let's do another one. Let's do the reference angle of 140 degrees. So again, we need to figure out where 140 is. There's 90, there's 180, so 140's got to be somewhere in this quadrant. And once again, the 140 comes from our initial ray to our terminal ray. And we have said that the reference angle needs to be the smallest angle from the terminal ray to the x-axis. The biggest mistake that most students make is they think that this is going to be your reference angle. You never get a reference angle to the y-axis. It's always to the x-axis. So in this case, we have 180 degrees here still. We have 140 to here, so to figure out the gap there, we do 180 minus 140. And we get a 40-degree reference angle. Okay, so that is our reference angles. Now we're going to do a lot with this. You'll be working on this in class. We're not going to really go over any more examples now, but we are going to need to be able to apply our reference angles. This isn't just about, finding a reference angle and then we're done. To actually get exact values of sine, cosine, and tangent and the other trig functions, we actually need to be able to find a reference angle. So let's move on to the next part. So this is the next most important thing that you're going to need to know. These are your special right triangles. Now I know that in geometry, you did a little bit of work with special right triangles. And it's really important for you to know these. You need to know the sides of our special right triangles. So this right here is a 30-degree angle. But notice the 30-degree angle, always opposite of our 30-degree angle, and you can see this on your paper a little bit better, is 1. The adjacent side, that's 1. The adjacent side to the 30-degree angle is square root of 3, and the hypotenuse is always 2. Now, another reference angle is 60, which is the same triangle as over here. It's 60 degrees as our reference angle, but notice the sides are still the same. Adjacent to the 60 is 1, opposite of the 60 is square root of 3, and the hypotenuse is still 2, but it's still the same 3 sides. It's just different because of where the angles are at. Always opposite of 30 is 1, always opposite of 60 is square root of 3. So now we're looking at the 45-degree angle. That's another special one. And the sides here are square root of 2, square root of 2, and 2. So if you have a 45-degree angle, we have square root of 2, square root of 2, and 2. This is going to become very important because if you look down at the next slide, this is what we call the unit circle. And it's a little bit easier to see on your paper, but you can see as we go around the circle, we are giving all of these different values. And where this is going to become important is you can see that here's our 30-degree angle. There's going to be our special reference angle, and we get these values. There's our 45-degree, we get these special values. There's our 60 degrees, we get these special values. Well, the thing is when we go around the circle to a new quadrant, we are still going to be using those as our reference angles. That's why we find reference angles in the first place. For example, if I want to go to 150 degrees, if we were to draw a line from here to our 150 degrees, we would need to be figuring out what our reference angle is. We're not really, if I want sine of 150 degrees, we can't just assume what 150 degrees is. We need to find the reference angle. And the reference angle to that would be 180 minus 150, which is equal to 30. So once we know that 30 is our reference angle here, we can then use our special right triangles up here to help us come up with what the solution is. Here's our special right triangle. We go to a different quadrant and label it accordingly, and then we can figure out our values based on opposite over hypotenuse, SOHCAHTOA, whatever we're using in that instance. Now, when you look at this unit circle, you should notice that there's all these coordinates going all the way around. We need to remind ourselves that sine is our y values, and cosine is our x values. So if you wanted to know your sine or cosine of any of these angles going all the way around, your sine of 30 would be your y value. Your cosine of 30 is going to be your x value, and that will always work. But what we want to do is we want to get into how do you do it without memorizing this circle? Because I've seen over the years, people remember the circle, they can fill in the entire circle, but if I give them what's on the next slide, sine of 150 degrees, they have no idea what the answer is because they have not made the connection that sine of 150 here is the same as the sine of 150 up here. So let's go through and how you should be going about solving these. Sine of 150 degrees. So what do? We want an exact value. So the first thing you want to do is locate where 150 degrees is on your graph. So that's going to be somewhere in this quadrant right here. And again, that's from our initial ray. So there's the 150 degrees. You first want to figure out what your reference angle is. So our reference angle, we just did it previously, is 180 minus 150 equals 30. So there's our 30 degree angle. Then what we want to do is we want to create a triangle out of this 30 degrees. Because now we can use our special right triangle. So if we go up to the previous slide up here, our 30 degree triangle opposite is 1, hypotenuse is 2, and the adjacent is square root of 3. But we need to make sure that we label this according to where we're at on the coordinate plane. So this is still a y value that's positive, so that will be 1. This is an x value that is now negative, so it's going to be negative square root of 3. And then the hypotenuse or the radius of our unit circle is always positive, and that's 2. So now we look at sine, which is opposite over hypotenuse. Our opposite side is 1. Our hypotenuse is 2. So the sine of 150 degrees is equal to 1/2. And that's an exact value. Okay, let's go to the next one. Cosine of 300. So once again, we want to locate where 300 degrees is on our graph. 270 is down here, so it's going to be somewhere down here. And again, that would be all the way around. That's our 300. Now, to figure out the reference angle up to the x-axis, this is 360 degrees right here. So we would do 360 minus 300. That means that the angle that we have left over is 60 degrees. So if you refer again back to our special reference triangles or reference angle triangles, opposite of 60 is square root of 3. But again, because we're below the x-axis, we need to label this as a negative square root of 3. Adjacent to the 60 is going to be a positive 1 because we're to the right. And then our hypotenuse is 2. So cosine is adjacent over hypotenuse, which is equal to, again, 1 over 2. So we got 1/2 again. All right, moving on to the next one. Tangent of 225. Again, find out where 225 is on your graph. There's 225. Our reference angle is going to be 225 minus 180 is equal to 45 degrees. So we have a 45 degree reference angle and triangle. Opposite of 45, in this case, is negative because we're below. Negative square root of 2. To the left is, again, negative square root of 2. Our hypotenuse is 2. Tangent is opposite over adjacent, which would be negative square root of 2 over negative square root of 2. They cancel out to be 1. The negatives cancel out and the square root of 2 cancel out to be 1. So when you're looking at this, you want to make sure that you are finding your reference angle correctly. That is for sure key, is finding your reference angle correctly. But then you also want to make sure that you are understanding which one is the x value, which one is the y value. You want to make sure you're labeling your negatives correctly and your special right triangles. So there's a few things that you really need to memorize. You need to memorize your special right triangle sides. You have to know what sides go with what. That is absolutely important. Okay, so that is the number one thing that you have to memorize. That's one of the rare things that I want you to memorize is the sides of the special right triangle. All right, so we're going to have to continue this and do another video, so just click on part 2.